and I've got everything where I can see it, so we're in good shape. Okay, again, I'm in my Colab notebook, which I operate out of. But the if we go back to the resources, the one that you want to use this afternoon is the ASRI 4 Introduction to Basic Statistics on Pandas Data Frames. And we will be using the housing price data again as our basic example tool. So those are the things that you will need to be using. So you need to move, if you haven't already done it, move ASRI 4 into your Colab folder so that you can use it, and make sure that you still have the housing price data, because we're going to make use of that data this afternoon. But both of it's all in the student binder if you need new copies. So I'm now going to go back to the system on my computer, and I'm going to start number 4. So if you're a data scientist, you typically have large amounts of data, and you need to extract insights from it. One of the most common tasks in data science is to predict the behavior of a continuous variable based on one or more features. And one of the tools for that purpose is linear regression. And Pandas makes it simple to perform linear regression on your data. I will forewarn you that we aren't actually going to learn machine learning until next week. But I'm going to use a machine learning tool to do the regression, which I'll show you how to use. It'll be sort of a preview of machine learning for next week. But it turns out that if you use the machine learning tool for regression, you get much better results than if you use the simple one built into Pandas. And the machine learning one is actually easier to use as well. So I'll just show it to you as the basic method for doing regression. I'm going to use the data set that we used this morning to illustrate it. The results won't be particularly useful or that good, but we'll be able to learn the technique with data that we've looked at before, and that we know that you can upload. And after you see the basics of the method, so Gary Kaya, thanks. You turned off your microphone. Anyway, once we learn the basics of the method, you will be able to apply the same methods to your own data sets, and we'll repeat some of the exploratory data analysis that we've already done to gather the information we'll need to determine the columns we should use for regression analysis. And what we're going to do, or I say what we're going to do, is link our Google Drive so we can load the data into a data frame. But actually, since we have the basic information already loaded on your computers, and since it wasn't working quite right this morning, since I'd set this up to use the simple method, what we're actually going to do is use the direct method. So there was a question in the chat about how to find Colab. The easiest way to find Colab itself is to actually Google it. But the link you probably want is the one to a folder, and then put that into your own Colab notebook folder on your Google Drive, which is on your computer. So anyway, Brianna has helpfully provided the key link to someone. So I'm not going to use the direct connection. What I'm going to do is the upload method instead. So what I'm going to want is that housing price data. So I'm going to go to the file folder. And then and you can see that my Google Drive is not linked because the option I have is to mount it, not dismount it. But I don't need it to be mounted because what I'm actually going to do is I'm going to upload the session storage by clicking on the arrow, and you can do the same thing. And the so what I need to do is to find that housing price data folder again, which, as you'll remember, takes a while because I've got a lot of things in my downloads. So, okay, here it is. So, what I'm going to do then is I'm going to open this, which will put it into local storage. It gives me the reminder to make sure I've got it stored somewhere I do. And so just like this morning, I now have housing price data available to this Colab notebook. And the same thing, you'll need to do the same thing. Actually, it wouldn't hurt if you uploaded both it and the data file that you want that you're going to be working with, so that you can actually use both of them. So the first thing that we've got to do is we have to load that file. And again, I've got the code block for how to read in a file with paste here in it. And then I've got another version without the comments and with a space about where I'm going to paste. And I need to get the address. So I allow my mouse to hover over the housing price data file. I click on it. I copy the path and I paste the path into the space that I left for it. So this will create a data frame named housing, which I introduced with a capital letter for this afternoon. And then I also did what I usually do to make sure I get a data frame uploaded. I've asked it to get the type of object, and so I'm getting the type of housing. As we'll run it, it will do the upload, and it tells me I've got a data frame loaded. Okay, and I'm going through these steps because you should always go through these steps when you upload a data frame, because they don't always get uploaded properly. So I'm going to take a look at the head and tail. And remember, you can look at both the head and tail simultaneously by just typing info. By just typing the name of the data frame. So it gives me the head, it gives me the tail, everything looks fine. So I can proceed with that. And we've got a variety of options, one of which wasn't there this morning. So let's click on this one and see what it's just another opportunity to generate code. So there's also a shortcut to generate code now. Don't need that at this point. I might want to take a look at the recommended plots, but since we've already looked at that this morning, I'm not going to do that. I will get the basic information about the data frame, which tells me that what the names of the columns are, how many of them there are, and how many entries there are. So so up to this stage, aside from the fact I looked at the head and the tail simultaneously, we have done nothing different to what we did this morning. So I also would like to run the correlation function again. Again, it's the same thing, and there's no high degree of correlation. There are no inverse correlations in this one, but I also now want to do something to show you how to make this look more attractive. And there is a product called Seaborn, which basically can make the graphical output of both Matplotlib and Pandas look better. And the what I'm going to do is I'm going to import Matplotlib, and I'm going to import Seaborn because I only need them to do that, because notice in my correlation analysis, I really just did that from what was readily available. At some point I'd already imported Pandas further up, so Pandas is already available. So in addition to Pandas, I'm going to need Matplotlib, or at least the PyPlot part of it, which I've imported as PLT, and I've imported Seaborn as SNS. And again, that is the standard choice that people make for Seaborn. And if you look at this, I first calculate the correlation matrix, but then after calculating it, I do this heat map that I create. So it's a heat map of correlation, and as well as doing that, I have asked it to annotate the heat map. And what that does is that it basically will put the correlation values on the heat map as well. So let's run this piece of code and see what it does. So in comparison with the correlation that we got before, you can see it has the same labels, except the labels are in different places. It has the same numbers, but it also does the things. It creates a heat map, and so the lighter colors are the highest correlations, and you can see from the diagonal what a correlation of 1 looks like. And then you can see that it shifts to orange, to red, to purple, and then on into the black as the correlation drops down. And you can see that the correlations with low numbers are extremely low. And again, with all of these code blocks, if you want to test something out and see what would change, you can do that. And the so if by nominal, so somebody asked, could you do a heat map for nominal values? And if you're talking about those ones that have verbal entries, it's only for numeric data. But anyway, what we can do is we can experiment with this. And so what I'm going to do is I'm going to go to this annotation true. I'm going to copy it, and then what I'm going to do is I'm going to delete it. And then I'm going to rerun the code block and just see what happens. So you can see I still get a heat map, but it is still, I mean, it still shows what is correlated, but I think it's useful to have both the numbers and the colors there. But your mileage may vary, so if you decide to show a heat map for your data, you might just want to show the heat map. I prefer it with the numbers, so I'm gonna go ahead and put them back in. But the basic thing is one of the reasons behind giving you these notebooks is so you can play with them and see what happens. Not everything's going to work, and the but the but you can find out what does and what doesn't work, and you can always reload the previous copy if you lose what you've had. So that's a true heat map. And if you decide to run a correlation analysis on the on your data frame, then I would recommend that in your presentation you show the heat map version because it is much more visually striking. It's much easier to immediately interpret the results, and so for a visual, a heat map is what you would want. And the name is from the colors, with the lighter colors being hot, and the darker colors representing cold. So I kind of explained some of the things I've already said for you in the text. Let me also say you can customize the appearance of this heat map basically by adding some figures. And so what I've done is to the command. Now remember, the correlation matrix already exists, so I don't need to create it again. All I'm going to do is I'm going to run the heat map software. If I hadn't ever run it, I would have to run that as well. But I can just run the heat map piece to get another heat map. And what I've done is I've specified a font size of 12. I've set a line width of 0.5. And I've also this time picked a color map and the of cool warm, which will produce a heat map, but it will have different colors. So let's see what we can do, what happens with it. So you can see, first of all, by specifying that line width, I actually have a gap between each of the boxes, and you can play with the size of the line width to produce a bigger gap. I mean, I could easily switch 0.5 to 1.5, and you can see we just get bigger gaps. So that's a way of uh, I prefer 0.5, so I'm going to switch back. But you can see in this the highest degree of correlation is represented by red, and the lowest degrees of correlation are related by blue. It's still as informative, but also like the fact that the numbers are easier to read because I set a font size, which resulted in larger numbers. And you can see that in this one, the color of the numbers also flips for readability. And that's part of the cool warm feature. So it basically has done the same sorts of things. You can use heat maps to visualize correlations on any pandas data frame, and essentially, the purpose of this is to find relationships that you may not have been aware of, either linear relationships or direct relationships or inverse relationships. And one of the things that you are going to want to be able to do is to find which columns. So you want to know if one column depends on the value of another column or is related to it in some way. And this is what the heat map can quickly tell you. It can tell you which pairs of columns it's interesting to look at, and which pairs of columns it might not be so interesting to look at. So now that we have seen correlation and modified it into a heat map, that would identify columns that we might try to look at the relationship in. And so at that point, it would be time to look at doing a regression analysis. Linear regression, which is what we're going to look at, is a statistical method that models the relationship between between dependent and independent variables. The goal of regression is to find the best line or a line that's the best fit to the data that minimizes the errors between the predicted and actual values. The predicted values, although the values along the line, and the actual values are the one that you get. The simplest form of linear regression is y equals mx plus b, which at some point you will have seen here. X is the independent variable, y is the dependent variable, m is the slope of the line, and b is its intercept on the y-axis. This is the standard equation of the line, and it appears in lots of contexts. Turns out it's the tool for regression or the simplest tool for regression analysis. If you look into digital filters, it turns out it's also the simplest digital filter for filtering data. So the equation for the slope of a straight line and the slope intercept form is actually a much more widely available tool than you might think. So there's a simple process for doing a regression with a pandas data frame. There are 4 steps. Load your data into a pandas data frame. We've done that. Prepare the data for linear regression by separating the dependent and independent variables. We haven't done that yet. Then create a linear regression model using the sklearn library. sklearn is short for scikit-learn, which is another Python module which implements the basic machine learning, which is the easiest way to do a linear regression. So what I'm going to do is I'm going to look at the correlation matrix and look for good candidates for linear regression. So if we go back to it, one of the things is our highest correlation index in this one was price versus area. So that would be a good one to run correlation on. Bathrooms would be next, but there wasn't very much variation in the number of bathrooms, so probably it won't give us a very good or very useful regression line. But so we'll do area versus price. So as I said, in the in our analysis, X is the independent variable and Y is the dependent variable. So in other words, in a graph, the variable along the horizontal axis is the variable that's independent, and the variable along the vertical axis, the y-axis, is the dependent variable, and that means that's the one that whose value you are trying to predict. So what this linear regression allows you to do is, given an x value, it allows you to predict what a y value will be. That's what the meaning of this equation is when we're looking at linear regression. So what I've done here is you notice that I've written X is equal to housing, and then I've put square brackets, and I have put area inside it, and then I've also done price, and so I also see that I've got two square brackets. I don't think that's necessary. I also don't think it hurts anything, so I'm not going to change it for now. We'll if our model will plot, we'll know that's the reason. I'm going to run this piece of code, and so we have it read in. Of course, you could replace this with columns and will replace this with columns from your own data frame. Now, what I need to do is I need to create a linear regression model. And again, I'm going to use the scikit-learn library. And it provides, that library provides tools for data preprocessing, model selection, and evaluation. And the way that we do it is from scikit-learn linear model, I'm going to import linear regression. So I'm only going to import one piece out of it. And then what I'm going to say is my model is going to be linear regression, and what we need to do is train a model and evaluate its performance. That's what we do in the statistics and data science. So I'll run this piece of code. And again, it just ran, there's no output. And now what I'm going to do is I'm going to train it, and then I'm going to evaluate its performance. So I'll first model the fit using X and Y. So it's telling me it's done the linear regression. And now I'm going to evaluate the model. So what we've got is now I've got an R squared value, and the R squared value measures how well the linear regression models the fit. It ranges from 0 to 1, and you can see that we got 0.28 squared value, meaning it's not a very good model. But anyway, so If you want to learn more about linear models, I provided some links for you, which I plan to look at here. So, this basically is an introduction to linear models in general, and I know you're learning some statistics, but I don't know what you have learned. But this basically shows you how to do that, and it gives a lot of examples, and it does some far more complicated things than that you will want to do. But essentially, you could probably restrict yourself to just the first sessions here on ordinary least squares, and that's probably as much as you would want. You could also follow the link to linear regression, and it will tell you all more things about it. So if you want to know more about scikit-learn, you can look at it there. I will tell you, I'm going to show you more about it next week. But if you want to get a head start, that's where to go. The other thing is that's important is you might need to know more about learning it in Colab, and I've also provided a link to a resource that tells you about that. So we'll follow that link, and essentially what this one does is it takes you through data representation. It takes you through a lot of things, and it shows you how to do a number of different techniques, and it shows you how to model and all of those sorts of things. And again, this is really foreshadowing what comes next, because I'm actually going to show you how to do much of what's in this particular notebook next week. I'm not going to follow it exactly, and I'm going to show you some different things. But I will probably use this iris data set, and but if you want to get a preview of what you can do with machine learning, that is the link to follow. So I had the double quotes in there. It may be that they aren't necessary. Maybe they are, because now it's generating an error for me. So perhaps you have to put double quotes. I was thinking that might be the case. You might have to put double quotes around the independent variable, because when I take them out, it tells me that it's. Now let me try taking them out again and see if it gives me an error. Didn't get, it was complaining about how I did it, I think. What I'm going to want to do is I'm going to run it and see if it makes any difference. Yes, it does. So apparently you do have to have the double quotes on the independent variable. Sorry, the double brackets. So now we're back to where we were. I can run that again. And I'll run this again. Now I got to clear it, the output first. Oh, actually, I missed this. So if I run this and then run this, it's back to operating. So let me make sure I didn't miss a step because I think calling it X ought to be enough. It is. So we'll run that. We'll run this. Then we'll run this. Yep, you have to have both brackets. Well, that's good to know. So the take-home message here is the double brackets are representing the independent variable. I'll go ahead and rerun the steps. Okay. I'll just make sure that the R squared value comes out right again. Yes, it does. So now I've said that the predictions are poor. Let's explore that. And the so let's do the prediction using X as a parameter. So so basically, this is some code that allows me to see the predictions, and let's just run that piece of code. And having done that, I'll now produce a scatter plot of X versus Y. So that indicates to you uh, how bad the model is. And now what I'll do is I'll put in our predicted curve in there. That's our prediction curve. And what we would like to do is we would like to see these in a composite plot. So I'll do that. So essentially what we've got here is this is a compositive plot. So the red line is our predicted line. Uh, the uh, blue dots are the actual data, and so you can see why the correlation may have been so bad. So that's basically an introduction in how to do a correlation, and it is something that you would want to do, and then you can start running the linear regressions and producing composite outputs like this to see how well or how poorly your predicted regression matches the data that you have to deal with. So that basically is is the simple way to do linear regression, which is something that some of you will want to do during your projects, which is why I covered it today when we're not really doing machine learning until next week. If we waited until Tuesday for me to show you this, you probably wouldn't have time to include it in your project because most ASRI participants complete much of their project during the weekend between the first full week and the second week, and they're working on that presentation during the second week. So I wanted you to have the linear regression tool available without you having to go out and dig out how to find how to do it yourselves. So anyway, that basically is how to do it. So the next thing we're going to do is we're going to look at how to do some basic statistics. Gideon, you've got a question. Go ahead.
Oh yeah, thank you, Prof. Yeah, I was gonna ask, when you have the white bread in the code there, so can you explain what that actually means in statistically? The white bread.
Uh,
That yeah, where
so
you have the
so
plots. The,
so basically, what I mean by y pred is the predicted value of y based on the linear regressor, which is the model. And so basically, what I'm saying, what we're saying here is predict. We want to know what is the predicted value of y based on this, and this is just the standard method for writing the code. Now, as I said, what we were doing here is we were getting a an early view of machine learning. So actually, I'm going to come back next week on Tuesday and Wednesday and talk more about this, and I'll talk more about those details. What, but at this point, if you've got variables you can call x and y, though, you can replace housing with whatever you call your data frame, and you can extract an x variable and a y variable, and you can then produce graphs like this. So essentially, the particular details of why that was picked, I'm gonna talk about more next week. But I wanted to give you a piece of code that you could work with. And that in the event that you decide that you need to do a an example on linear regression. The question is, do you do an example of a logistic regression? I might. But that will be something for next week. The that isn't in the basic plans for beginner Python, though, because the thought is that for people just beginning, they're unlikely to need to have to do a logistic regression. But since you have asked, I will make a note of it. And I'll make sure that I show you how to do a logistic regression either on Tuesday or Wednesday of next week when we're going to be looking at machine learning. Probably on Wednesday because the Wednesday session is basically based on how to pick different machine learning models. So I will do one for you. But if you are gung ho to find out how to do it before then, what you might do is go to ChatGPT and ask it to show you how to do a logistic regression using pandas and scikit-learn, because it probably will do that for you. I know that some of the LLMs will. The That may not be the best one, but it probably will at least give you a reference. Any other questions? Okay, we're going to look at some basic statistics next, but what I think we will do is in order that you have a break, what I'm going to do is I'm going to basically have a break at this point. So it's 1:37. So let's take a break until 1:45, and we'll resume at that point and looking at statistics. I'm going to show you some basic statistics, and then what I'm actually going to do is I'm going to show you how to use the pandas documentation so that you can find out other things that you might need to be able to do, because there's no way I can show everything that everybody might want to do in the time that we have available. So basically, I'm going to show you how you can find things and how you can find some instruction on how to do things that you might want to do for your project. But let's take a break at this point, and I'll see you at 1:45. So I will mention that when they upload the video from this morning, our break is in there. I'll let the recording run. So if you view that one, just fast forward through it. But this time I remembered to turn it off, so we won't have that problem. So let's go back to the screen share. And set it back so I can read chat again. Okay, I'm back up and running. I've got a few more things to show you, and the one of those things, or some of those things, are using statistics. So we've still got our data frame, so I don't need to reload it. But what I want to do is to show you how to calculate basic statistical quantities, because the likelihood is you are going to need to know some of these things, or you're going to want to know some of these things for the data that you have. So it's nicely laid out into blocks. So the first block will calculate the mean for you, and so the question that we'll answer is, what's the average number of bedrooms in the houses in the data set? And so the way to do that is we need to take the data frame housing. We need to just focus on the column bedrooms. And then we are going to apply the mean calculation to it, which is what is done in this code. And we can see that the mean is 2.965. Now, specifying the sort of number, by the way, is a recent change in Google Colab. It just used to spit out the number, and I may spend some time this evening figuring out how to make it go back to its old behavior, because I find it annoying that it tells me that it's a 64-bit floating point number, which was using the NumPy version every time. But that's what it's going to do, apparently. So anyway, that gives us that. And one of the things that you should do when you calculate things like that is to ask yourself, does that number make sense? And so if we go back up, well, Well, I guess we did that this morning. But if we look in the data, you can see that the number of bedrooms are typically, twos, threes, fours, things like that. So the number does make sense. So the next thing is we'll calculate what the median number is. Same basic setup, except we replace mean with median. So in this particular case, which didn't have the annoying number type on it, it tells us that the median number of bedrooms is 3. So that's the halfway point in the data in the data set. And the next thing is we could ask also for the mode, which is the most commonly occurring number, and that's done in the next line. So interestingly, we got two numbers. Let's put another code block in and paste that, but change bathrooms to bedrooms and calculate the mode of it. So anyway, it's the modes are obviously 1 and 3. I don't know what that 0 is sitting out there. Again, they've actually changed how some of these things work. You might want to do multiple columns at the same time. So what I'm going to do here is I'm going to get multiple quantities for multiple columns. And what I'm going to do is I'm going to get housing. I'm going to take the columns price, bedrooms, and bathrooms. I'm going to apply the function describe. And we'll see what it does for us. And you can see it gives, and so what this means is if you really want to do this, it gives the numbers for a variety of different things. So if you want to describe, get the numbers, rather than getting all of these things separately, I would use the describe function, at least if it gives the things that you want, because here what we've got the count, which is the actual number. So it gives the total number of bedrooms, gives the total expenditure as well, which I suppose is not that useful. It gives us the total number of bathrooms. It gives us the mean number of bathrooms, the mean number of bedrooms, and the mean price. It gives us the standard deviation. It gives us the minimum number of bathrooms and bedrooms and the minimum price, and then it gives the 25th percentile, the 50th percentile, and the 75th percentile, and also gives the maximum. So basically, the maximum number was 1.33 times 10 to the 7. The maximum number of bedrooms was 6, and the maximum number of bathrooms was 4. So That tells us quite a lot about the data set, but uh, we wouldn't want to describe about an entire data frame because these quantities don't make sense for some of the quantities. So pick the things that you're interested in to get a description on from your data frame. So the what if you wanted just to do a standard deviation? Well, in the next line, I've got the code for how to do a standard deviation. So so basically, I've got housing. I've picked bedrooms and bathrooms, and I'm asking it to do the standard deviation. And so you can see it gives me the standard deviations for both bedrooms and bathrooms. And if we wanted that, that would be the way to do it. So the can also just do bedrooms, and basically you just do. So the upper piece of code is how to do multiples, and there we need to pass the list to an indexing operator. For a single column, we just do it that way, and I give you examples of both because you might need to do both, and you can put as many things as you want in the multiple, and that's how the single column works. You might want the variance instead of the standard deviation, and so there is that. And you might want the a variance of multiple columns. You can do that. And the other thing that you might want to know, and biologists frequently want to know this, is what's the standard error of the mean? So this is the code for it. We'll do it on bedrooms, and it's 0.03. So basically, those are all of the basic descriptive statistics pieces that you are likely to need. So I've got a direct message here, so let me read it quickly. Well, the question I guess got answered, which is the question I was asked: is there a way of the summary statistics can be computed in one code instead of individually one code at a time? And the answer is yes, because that's the describe method that I used here. So essentially. But describe only does the things that it wants to do, and so it picks. For instance, if you wanted the variance, it's not included in describe, and if you wanted the standard error of the mean, it's not in describe. But if the count, the mean, the standard deviation, minimum and maximum, and percentiles are all you need, that's describe will do that for you. Okay, there's a lot of other things that you might want to do, and so what I actually want to do at this point is to spend some time looking at the documentation. So it says if you need more statistics, you can look them up in the pandas documentation. So let's follow that link. And this takes us directly to the documentation. But what if I hadn't gone? What if I went to the main page instead? Let's try to do that. Well, let me locate it from Google. So if you end up on the front page, how do you navigate to the pieces that you need? So this is the front page, and what you are going so Gideon asked the question, can we use describe for all the variables instead of the selected columns? And the answer is, if you do that, you'll get garbage out because some of the columns are categorical and not numerical. And not every function in pandas will automatically ignore categorical data. I don't know about describe because I usually just pick columns. But I mean, you can try it and see. But if it balks or if you get garbage out, you'll know that it's actually safer to pick the columns you're interested in. Anyway, so if you click on documentation, though, it takes you back to this page, and notice that there's getting started, there's a user guide, there's an application programmer's interface, and there's a developer guide. So what we want to do is getting started, and I'm going to click getting started along the top of the page, and what you can see here that there's a lot of things. There's an introduction, what kinds of data, how do I read and write, and so on, how do I select a subset, a lot of the things that you might want to do, and you can go to the tutorials. The other thing is you can click on these getting started tutorials, and it will bring up a tutorial of most things that you want to do. So so we've done some of these things, but let's look at the first one. So
Pardon everybody the interruption, but it is 2 p.m., so we're about halfway through our session. If you want to take a 5 to 15-minute break, whatever the professor in the room will say is okay. And if I interrupted in the middle of a sentence, please forgive me and finish whatever it is that you were doing. Thank you.
She won't get that message. The chat only goes to the people in the room. Yes, we already had a break because breaks are best taken when the material dictates, not the clock, and it rarely happens at precisely halfway through. But anyway, so if you want to know about this, it explains things in sometimes excruciating detail. It talks about PD being the assumed practice as the abbreviation. It talks about how to create a data frame. It relates it to a spreadsheet, and it does all of that, and it introduces the describe command and things like that, and it shows you where to go for more. So the tutorials are quick, but one that I'm sure that somebody is going to need is, how do I select a subset of a data frame? I've shown you how to pick columns, but this will show you more. So in this case, they're using the Titanic data set, which I'm actually going to use maybe tomorrow. But anyway, the Titanic data is a data set which is it's a real data set about the passengers who sailed on the Titanic, and it includes the passenger IDs, what they paid, whether they had a cabin, how old they were, and things like that. But anyway, it's one way you might want to select columns. So basically, if your data frame looks like this, you might only want to look at these pieces. So if if you just want to get out a series element, which would be one column, you can just say ages is equal to the data frame Titanic Titanic, just select the age, and that will give you a series object that just has ages in it. And the each column in a data frame actually represents a series. So it shows you how to do that, but you might be interested in more. So if you're interested, for instance, in both the age and the sex, you could take the data frame Titanic that you'd obviously have to have uploaded the file and select out the columns age and sex, and now that gives you a new data frame that just has those two columns in it. So basically, that shows you how to do that. If you want to filter rows, it shows you how to do that, and so basically, this is how to pick out rows, and it shows you how to put a condition in there in code, and so what it's done here is it's taken the age column. It says you're interested in people over 35, so it's saying take that column and only give the passengers above age 35, and you can create a new series then for the above 35s. And it shows you, I mean, depending on what you wanted to do, it shows you how to do that. It shows you how to select specific columns. And so my guess is that if you look at a tutorial at all, this is the one that most of you would want to look at. And because the likelihood is you are going to want to select a subset of your data frame. And so basically, this then would be how to do it. Get back to the tutorials. So what else do we have? How do you create plots? If you look at that one, you'll see it does, it's much like the ones that we've looked at, shows you how to do the same sorts of things. Actually has a better box plot example than the one I gave you. But really shows you how to do several different sorts of plots, although not all the ones that we looked at, but it is another source. So it shows you how to create new columns. You might want to be able to do that. How to calculate summary statistics. I mean, that's what we've just been doing. Means, medians, describes. Shows you how to group things together. So it shows you a few things I didn't show you, but my guess is you won't need to be able to do those things. Let's see, combining data may be a possibility, and so there is code for combining. My guess is you won't need to be able to do that, but if you did, that would do it for you. Somebody might have time series, and so if you've got time series, this shows you how to do some basic things with time series, and so working with dates. So if you've got data that has dates in it, you might want to be able to plot those over time, and there's direct instructions on how to do that in the time series tutorial. So that's another one that you might want to take a look at. So let's see. The other thing is you might want to do some things with text data, and So if you do, you might want to, this shows you how to extract surnames, for instance, and it shows you how to extract some specific information based on a variety of things. You may need to do that, and it also shows you how to replace string data with a different string and things like that. So my guess is if you need to follow the pandas documentation, nobody will need to go further than is in these beginner tutorials. They will tell you everything that you need, and basically the questions are, you can get them in a question form as well. There is the user guide, and it tells you how to read the guide, and then it gives you all sorts of topics. Okay, so for instance, you could go to time series here, and time series in here is quite a bit more complicated than time series was in the beginner guide, and there's not so much advice given. So I would start with the beginner guide because it's probably gonna be what you need. Um, if you discover that you have files other than CSV files, and it may be that you decide that you need some additional information, and you find things on your own. Here it tells you how to deal with all sorts of files. So you might, for instance, need a JSON file, and it tells you how to deal with JSON files, but look how complicated the description is. And actually, let me go to the Excel one. So it tells you how to read Excel files. But so basically, here's the instructions on how to read an Excel file. It doesn't do it really easily, and so one of the reasons for showing this is, if you needed to read an Excel file in, what I'd recommend doing is simply this. Go to Google and just type in, how do I load an Excel file in Pandas? And so it takes you to the documentation, but it also takes you to lots of things. And so one of the things that people who program for a living do is use something called Stack Overflow, which is one of the things here. So it's going to verify I'm a human. So, but going to Stack Overflow, it will give you some examples about how to read in the pandas, and there's a lot, and there's always going to be there's a much simpler and easy way. And notice it looks just like we did for our CSV files. Data frame is pandas read Excel instead of pandas .cbs, and just give the name. So basically, if you need another sort of file, this is a place where you can find it. Stack Overflow is a good resource, but there's usually going to be 10 answers to every question, and it's better to scroll down to the bottom and find someone who says, this is the easiest method. And so down here, this person said all of these work for me. If there's only one sheet, which most of the time there will be, he says this is the method that works. You might actually meet Excel files, which is why I particularly showed you that one. But anyway, let's get back to this. So I've shown you all of the statistics that I wanted to show you this afternoon. So what I'm going to do is I'm going to go back to the main ASRI 2025, which I think is one further back than this. Yes. And one of the things that I want to go through is, I says there was a PowerPoint that I may or may not go through. That's the one about variables in Python. So since we have a little time, and since I don't want to get you too deeply started in your project, I'm going to take a little time to look at this PowerPoint, which is about variables in Python. So I didn't expect to have time to present it, which is why it says this was not presented, but you may find it useful. But I want to point out a few things in here. So I originally wrote this because at one point we actually gave this to more than just my sessions. So what I'm going to do, we've already looked at arithmetic operations. What I'm going to do is focus on variable types and data frames, and the whole thing about pandas is it's necessary because Python doesn't do a great job of supporting arrays, and so we use data frames in their place. So I'm going to show you, though, that sometimes data frames are overkill, and that there are ways of creating objects in Python if you've just got simple amounts of data. So there in Python, there are lots of data types that can store multiple items in a single variable. And those things are lists, tuples, sets, and dictionaries. Those are just the names. Most of the time, you don't care which one you're dealing with, but they all exist. So to create a list, though, all you have to do is put in square brackets. So basically, if you wanted to create a list, all you would do would be to create a new variable called new list for, and then I put in car, boat, plane, and train, and you could print it with the command print. And it's ordered, and the items are indexed, and so this car is item 0, boats item 1, planes item 2, and train is item 3. But that's basically a list in Python. If you add items, they will be added to the end, and lists do allow duplicate entries. And to determine the length of a list, we use the length function. Now, you will notice that I used the length function on day one, on morning 1, and the length gives you the length of the list, and if you want to know what it is, you can just print it out. So I've got three lists here. The first one is a string list because we've got strings of text. The second one is an integer list, and the third list is Boolean because what I've got are there are things like true and false, which are the statements that you use in Boolean logic. But anyway. So lists, and they're amongst the most commonly used things in Python, come in more than one type. So then we want to look at what Python uses for arrays. The list collection is a collection which is ordered and changeable, and it allows duplicate members. A tuple is ordered and unchangeable. A set is unordered and unchangeable and unindexed, and it allows no duplicates. You probably will not ever use a set. So Prevalier asked what are arrays, which is a good question. They're the things that we've been using in data frames. An array is basically a two-dimensional list of numbers having rows, so something that has rows and columns. That's an array, and data science is built around arrays, and so the point here is I wanted you to know a little bit about them, and dictionaries are ordered and changeable, but they actually didn't used to be ordered until Python 3.7. So NumPy is a Python library, and among other things, it's used for working with arrays. It's short for numerical Python, and it also does linear algebra and general matrix operations. And the matrix is that mathematical array. We could use lists, but they're slow to process. NumPy is much faster. Arrays are the corner's realm in data science, and you've already seen this where we process data frames. So a matrix is a set of numbers in a rectangular array, and it's arranged in rows and columns. And this particular matrix has one row and three columns, and so this is called a 1 by 3 matrix. It's also called as it happens, a one-dimensional matrix is a vector, and you'll see this referred to as a bra. Because a row vector like this is called a bra in a variety of contexts. A column vector, which would be one-dimensional in the other way, is called a ket. But anyway. So here's a 2 by 3, and then this is an array because it's a two-dimensional organization of numbers. And this is a matrix that again, and it when you do arithmetic with it, you have to use matrix multiplications. So here's a 3 by 4, 4 columns, 3 rows. Their square matrices come up a lot. They have the same number of rows and columns, and if they're n by n and it's square, we call them of order n. So this is the matrix here is a square matrix of order 2. Here's a 4 by 4, which is of order 4. This one's called diagonal, and because it only has values on the diagonal, and everything else is 0. This one's called the identity matrix, and it plays the role of 1 in numbers. If you multiply a matrix by the identity matrix, you get back the same matrix. If you've only got zeros in there, it's called the zero matrix or the null matrix. And the matrices are only equal to each other if every element is the same. So those two are equal. But if we moved a number in one of them to another location, they would no longer be equal. And you can add matrices that have the same dimension. All you have to do is add the number of terms. You can do the same thing for subtraction. You can do a scalar multiplication, which basically means multiplying every term by the number in front. Sometimes you need to transpose them. So basically, what we've done here is we've taken the row here and made it the first column in this one. We've taken the second row and made it the second column. That's called a transpose. And then there is matrix multiplication. Now, the computer knows how to do this, but if you ever have to do it by hand, it's really complicated. Pandas is doing this for you, but the whole purpose behind this particular addition is people are going to use these words when you talk to them. So this was provided with the intent that you look at it, because if you're talking to people who are data scientists, they're going to have done some of these calculations by hand, and they're going to be talking about these things. But let me show you how matrix multiplication works. So if I take a matrix A, what I've got to do, and multiply it by B, what I've got to do is I've got to multiply this column of A by every row in B, and you can see that I've got a 1 by 3 and a 3 by 3, and when I make this calculation, we have to add the recipe is you have to add these up. It converts it into a single column matrix. If you do that, and this basically shows you the details and of how to do it. So I'm not going to go through that, but this shows you how to multiply two matrices together, and you get a surprising result. It doesn't match the size of either of the ones you started with. But ultimately, if you pursue data science, you will take a course in linear algebra, and you'll learn how to do this, but the terms like matrix and array will creep in. And so the purpose behind that is not that you learn this week, but that you have this resource available, and you try some of, you learn a bit of the language. So now what I want to do is I want to go back to ASRI 4. And for the time that we have left, what I want you to do is to you can use this data frame, but instead of using housing data, what I want each of you to do is to use the CSV file that you are going to be using in your project, and make sure that you can do the same sorts of things with your data frame that we've done today with the data frame that I provided to you, because one of the things that can happen is when you try to load some data frames, they might not load using the commands that we have given you. Now, I think we've got them all fixed for this year, but it turns out that a couple of years ago, a couple of the files that people used for data sets used an old-fashioned encoding, and so we had to fix that so they could read things in. So since being able to access your own data file is going to be really important both tomorrow and Friday, I want you to try it now. So what you're going to have to do is you've got a data frame presumably on your computer, or maybe on your Google Drive. So if it's stored in your directory in your computer, all you need to do to get it is to go back to the file thing here, and select. Okay, here we go. Select the upload to storage, and so add your folder to here where you can load it. And then what I want you to do is I want you to try the different things and just make sure that you're able to get them to work on your data sets. Also, while this is going on, I'm going to call on people and ask them to talk about their projects. So I'm actually stop screen sharing my screen for a while, so I can see everybody. And I'm going to ask people to talk about what they plan to do. So Lawrence King, you're sitting as the first person on my screen. So how about telling us what you plan to do, what data set you're looking at, and whether you think you've learned enough that you can start analyzing it.
Well, at the moment, I am looking into one of the extreme Earth events data sets, the full data one.
Okay.
And I am going to be exploring location and time correlations between earthquakes, volcanic eruptions, and landslides. See if I can establish causality and order of causality between them.
Okay.
Uh,
So an ambitious project. Is this the sort of thing that you want to pursue?
It's something that I would have wanted to do a very long time ago. As a kid, I wanted to be a volcanologist, and I just saw something I could do. Like, hey, this looks interesting.
Sure.
But no, I'm my field. I'm pure math.
Okay. So you're going to be a math major, huh?
Yes.
So do you have a data science option in your math degree?
Uh, I have not really looked down that way a lot. I got forwarded to this program via an email from a professor.
Ah,
They're just like, hey, here's a research opportunity I think you might find cool.
okay, okay. Well, if you find it really cool, for
Yeah.
instance, we have a data science option in our math degree. We also have the option for people to do a minor in data science. So what frequently what happens is our pure math majors get interested in this stuff and do a data science minor. You probably have something similar at your institution.
Yeah.
But
I'm
anyway.
at I'm at Arkansas State, so
God, I'm pretty sure that you do have something similar. So I know the data science folks at Arkansas State well. So I
okay.
know
Okay.
that they offer some similar.
Yes. This program it's made me get thinking about that.
Well, good. These are skills that so data science is one of the fastest growing professions, and it's a really good thing for math majors. Okay, thank you for sharing with us. So now, if you've asked questions, realize that the people who ask me questions are close to the top of my screen as you go along, because if you interact with me, you get moved to the front. So all the people I'll call on first are people who've actually talked to me. So Algelia, how about you coming on and telling us about what you plan to do?
All right. So I'm trying to figure out, or I'm doing the extreme earth events, and I am using the landslides data set. And so mine is quite simple, and I'm trying to keep it simple, just the correlation between areas that have high rainfall and how frequently those places cause landslides. So simple, I think it's like the linear regression, just to show that relationship between rainfall and landslides.
Okay,
Um,
well, I'm
yeah,
glad I decided to move linear regression up to this week then, because it'll
yeah,
give me time to do it.
for
In past
sure.
years, we haven't done that until the second week.
Yes, it was very
So,
helpful.
so good. Uh,
Mhm.
uh, so are you planning on following up with data science, or is this a first experience for you?
Yeah, this is a first experience for me. In the last 5 years of my professional life, I've never coded and didn't plan to, but I was like, the world is changing so fast. And I saw this actually on a LinkedIn post from a repost from a friend. So I just signed up. But now, kind of similar to what Lawrence was saying, now that I'm doing it, my background in my field is human factors engineering. So we relate a lot to user experience, machine learning, and human computer interaction. So I am looking to see how some of these concepts I can incorporate in my career as I learn it through the data science lens.
Sure. So one thing I'll tell everybody is, I think I've already mentioned I was a freshman in 1975. So I took my first programming course in 1973 when I was in high school. And I don't think a week has passed since then that I haven't coded up some problem or other, because it's a great way of getting answers quickly. And I think that overlies all professions. And you might have not, you probably saw me use some LLMs this morning. Pretty much, I use all of the computer tools that are available to me because they make life easier, and that's what it's about. And data science. Uh, so I think data science is going to impact every field. So it has. Um, things you can do with it you might not recognize. So, for instance, if you're an English major and you're studying whether an author wrote a particular book, it's actually possible to determine if an author wrote a book just by reading all of the words in and looking at the word frequency. And if the word frequency in this book correlates with the other author's writings, there's a high probability that they wrote that book. So, it's usable across a lot of fields. Anyway, thank you for sharing. Brianna, how about you coming on and talking about your data set? So, Brianna Blue, are you out there? So, she may have stepped away. Let's see. Gideon, are you out there?
All right.
So go ahead and
Um,
tell us about
okay.
what you plan to do.
All right, thank you. So I'm actually working on a data set from the area of pollination ecology, which is partly my field. And then I'm looking at, so it's actually a research I conducted sometime back in 2018, 2019 in Nigeria. And in that data set, I collected data on visit rates of birds and also looking at various environmental factors that influence visit of both birds and insects. So this time around, I'm actually working on that data set and carrying out a multiple regression to see some of the factors that have the strong effects on visit rates of birds and also see how much variation we have in terms of visit rate on looking at a temporal scale from the early morning of the hours till late evening. So that is the kind of data set I'm actually looking at right now.
Okay.
So it's actually a bigger data set, but I just extracted a part of it because I looked at temporal niche partitioning between both insects and birds, but this time around, I'm only extracting out of the birds to look at for now.
Okay.
Yeah,
So
exactly.
are you working on a PhD or
Oh yeah, I'm working on the PhD in the
okay.
area of evolutionary biology.
Okay, great.
Thank you.
So this will be really useful to you. What I find is that biologists have to learn more and more math. The When I started as an academic, most biologists didn't know any math to speak of, and then they started learning some statistics.
Yeah.
And then about 20 years ago, Springer Verlag brought out the first book on mathematical biology, and it was a single volume, and it summarized all the math that a biologist might ever be expected to know. I noticed that they have a new edition out now, and it's by the same author, but it's 3 volumes, all of which are fatter than the one that came out 20 years ago, and looks a lot like the math that physicists have to learn. So math is becoming more and more prevalent in biology. But
Especially in
anyway,
ecology.
yeah, it's especially in ecology,
Ecology, exactly.
but also environmental science is the other
Absolutely.
place that there's a whole lot of use.
Absolutely.
So anyway, but thanks for sharing and
Yeah, thank you.
good luck with the project.
Thank you so much, Prof.
So, Leiji, how about you coming on and talking about your project?
Hello,
Hello.
am I audible? Okay, all right. So this is the first time I'm coding in Python. I wanted to pick up a new language. So 2 years back, I did my master's in public health in epidemiology, and I got interested in quantitative data analysis. So that's how I ended up here. And now, so what I was trying to think is, I was trying to check whether there was the lower service counts of Medicaid and CHIP beneficiaries were associated with higher count of pregnancy outcomes.
Okay.
So I have a, data set, the pregnancy with very few variables. So the pregnancy outcomes included like miscarriages, stillbirths, and termination. So first I thought I will go for converting them into categorical variables, and then trying to do a chi-square analysis and multiple logistic regression by I think I got too ambitious. I thought I'll pull out, do some data wrangling and pull out other variables also. But now I'm trying to decrease my ambition and trying to go along with the classes. And maybe I'll end up doing a Pearson correlation and linear regression. That's
Okay.
what I'm thinking of right now.
Okay, well that'll be a good project, and the so thanks for sharing. I think so. One of the things is you can build on it. You've got to learn the simpler things first, and then when you get those working, you can build up to the more complicated ones. Sometimes. People try to jump in and do the most complicated calculations from the outset. And what they find is they can make the calculations work, but they don't understand the results. Because the results require you to be familiar with some of the simpler methods. And so it's much better to build up. And also, uh, the even if you worked on it solidly for 2 weeks, if for your original plan, I don't know that you'd have time to get it all coded. So the reduced plan is probably much better, but there's nothing that says that you can't keep working on it because in past years, well, I've talked to people. I'm still in contact with some people who took the course 4 years ago. Some people keep working on it and keep looking for additional information and really use the methods. I just say keep working on it and keep following up. Read some of the resources that we've linked, and you'll be able to build up to do those really advanced analyses, and also be able to explain them to people because you need to be able to explain them to people.
That's right. And I have just a quick question. I
Yes.
just want to use this opportunity for a question. So in the variables, I have a year variable, which 2017 to 2021, I guess, if I'm right.
Right.
So can I do a time series
Yeah.
analysis with
Yeah,
that?
that's exactly what you would want to do a time series on. So if you read that lesson in the Pandas documentation
Yeah,
about time series, it'll
yeah,
show you how to do that.
yeah.
And it has all the code examples that you need, and you can grab them out of it just like you can grab them from my workbooks. But that would be a good thing to do.
Okay. I just wanted to understand whether with year data we can do that or we just need monthly data itself or something like that.
Uh,
Okay.
One of the things that I run time series on are astronomical events, so for instance, I run time series on when eclipses occur, so normally I run those over 100,000 years. So yeah, you can do it over any length you want.
Okay. Thank you.
Thank you.
Yeah.
So Brianna, I think, is back with us. So Brianna, if you want to come on and talk about what you plan to do in your project.
Sorry, I honestly I thought I had the coffee thing on. I am so sorry. But so my project is going into looking at which industries specifically produce the amount of waste in 2018. So far I'm still a little weary about going through the data set because I mean it kind of is going a lot between like different items and trying to group like all the industries
Right.
like throwing like specific ones into together. So I guess one of my questions is, well, I'm wondering, is there a way in Python do you do like ANOVA testing or like how what does that kind of look like?
I mean, yes. The so we don't normally get that far, but you can do an overs in Python, and that's one of the things is. I mean, it's not as simple as the means and standard deviations that I showed you. But if you go to the Pandas documentation, it actually will show you how to do it. And also, the I mean, if you've got access to an LLM, you could ask how can I do an ANOVA on a pandas data frame, and it will tell you the code that will and give you the syntax that you need to use. I don't remember it offhand because I'm a physicist, and the data that I have rarely requires ANOVA, so it's not something I use frequently. I know it's doable. It's just that the sorts of experiments that I do don't ever need it. But you could certainly find that information relatively easily. And so if you want to look for it, and if you wanted to say on Friday, ask questions about it, get the code and try it out, I'd be happy to look at it with you and see if there are any problems. But Friday is going to be really given over to looking at issues that people might be having. So you could go ahead and get started on it.
Thank you.
Okay, we have had lots of time as people are talking. Anybody run into any difficulties in loading their data set yet, or any questions you want to ask about it?
Yeah, I think I will be needing help as well on Python because I want to run a linear regression model on my data. I'm working on the chronic disease indicator data set, trying to pull out those zip code with higher obesity, inactivity that are uninsured. And I want to see how their A1C, the A1C, I'm going to simulate that one. It's not there. I'm going to see if there the zip codes that are really going to show some improvement in their A1C. But I think it's somehow cumbersome. I'm still pulling the data set, and it's a lot of work pulling it manually from the data set. I was even asking if there's a way to pull the data easily or something, but it's manually. It's taking time. And then I'm going to need help on how to run the data set with a linear regression model.
So what I would suggest doing is, have the data set available where you can upload it. And then when we do some work sessions tomorrow, excuse me, and Friday, we can look at it and see what the issues are and give you some advice on how to move forward.
Okay. Thank you.
So I've got a question in here from Zainab, which is there a way to combine two data sets using Python? Well, the answer is yes. We'll probably show you how to do that either tomorrow or Friday, probably on Friday. But if you want to go ahead and do it now, I showed you actually the pandas documentation, and one of the things in there was how to combine data frames. And so what you would have to do is take the data and read it into two separate data frames, and each data set into a data frame, and then there are commands for combining the data frames. And so you might want to look that up. I'll show you some simple examples of it before the end of the week. But anyway, that's the place to go. So another question from Sahid is, how do I get objective fitness from a regression model? The answer to that is, I don't know, because it's not something that I do, but I'll see if it's easy to figure out and get back to you. So I also say, Zainab, that would be a question that's probably better asked of a statistician. I'm not a statistician. I know a lot about some parts of statistics, but I'm not a well-rounded statistician. So objective fitness is not something that has particularly come up in research that I do. But a statistician would, in fact, be able to answer that rather quickly. So Algeria having a tornado warning. Yes, take cover. We're through the main content for today. This is basically some time for people to try things out and maybe to get some questions answered so that they can try some things out tomorrow. But as I might have mentioned, they allocated me 30 minutes longer than I was expected than I expected for this session. So I was actually expecting to be done by 2:45. So anyway, so very happily, I'll say. Yes, leave your computer, do whatever you need to do, be safe. If you got a tornado warning, the world will wait for you. Okay, so we've got just a few minutes left. I probably am gonna let you go to break a little earlier today. But is there anybody who has some questions who that they have waiting? Just remember that it's better to ask the questions when I'm available. I'll be available for some help sessions, but I'm not doing any of the help sessions until next week because basically with teaching sessions essentially for 6 hours a day, I needed time to have lunch, so I didn't sign up for any help sessions this week. But if you have questions, I'll be happy to try to answer them or to write them down and come back and answer them tomorrow. So anyway, if you so unless anybody has any questions, I think we'll say I'll let you go early from this session today because I've covered everything that I wanted to this afternoon, and I'll see you tomorrow. So there is a question: is there a way to change data types of a variable in Python? Yes, it kind of happens automatically. Python is dynamically typed, so if you do a calculation that requires a variable to be a different data type, it will change automatically. Another question is, can we access the slides that you used today? Yes, they're in the student directory. Sorry, in the student binder. So anyway, so everything that I've used so far is available there. So anything else? Okay, I will. I'm gonna remember to stop the recording.